Did you ever wonder where did our own solar system come from?
Is our sun just an accident?
Are the precisely balanced orbits of its moon and planets merely the result of random explosions and outer space traffic jams?
Is it all the result of haphazard chance?
A jumbled series of gigantic accidents?
I am John David,
Nicole?
And I'm Clifford.
grade 11 students of Science, Technology, Engineering, and Mathematics,
Let us travel back in time 4.6 billion years ago.
and discover how did our solar system form.
And become as it is today through the following rival theories.
So without further ado,
Let's get started!
When it comes to the formation of our solar system, the most widely accepted view during the 19th century is known as the Nebular Hypothesis. It was proposed by a Swedish Lutheran theologian, scientist, philosopher, revelator, and mystic who inspired Swedenborgianism, named Emanuel Swedenborg. Also a German philosopher who is a central figure in modern philosophy, named Immanuel Kant. Lastly, it was also proposed by Pierre-Simon Marquet de Laplace, a French scholar whose work was important to the development of mathematics, statistics, physics, and astronomy. According to this theory, Sun and all the planets of our solar system began as a giant cloud of molecular gas and dust. Then, something happened that caused the cloud to collapse. This could have been the result of a passing star or shock waves from a supernova, but the end result was a gravitational collapse at the center of the cloud. From the collapse, dust and gas began to gather in one region. As it continues pulling more and more matter, it begins rotating and increases the pressure, causing to heat up. Most of the pulled matter form a ball at the center, while the rest of the matter flattened out into a disk that circled around it. The ball at the center becomes the sun, while the other materials form protoplanetary disks. Gas and dust are gravitated that form planets. Due to their higher boiling points, only metals and silicates could exist in solid form closer to the sun, and this would eventually form the terrestrial planets of Mercury, Venus, Earth, and Mars. In contrast, the giant planets, which are the Jupiter, Saturn, Uranus, and Neptune, form beyond the point between the orbits of Mars and Jupiter, where material is cool enough for volatile icy compounds to remain solid. Leftover debris that never become planets congregated in regions such as asteroid belt, Kuiper belt, and Oort cloud.
Next is the tidal theory or the sun-star encounter. It was proposed by James Hapgood, an English physicist, astronomer, and mathematician during 1917. Attempts to resolve the angular momentum problem lead to the temporary abandonment of the Nebular Hypothesis in favor of a return to two-body theories. First, the planets were considered to have been formed due to the approach of some other star to the Sun. Second, this near miss would have drawn large amount of matter out of the Sun and the other star by their mutual tidal forces, which could have then condensed into planets.
Next up, the planetesimal hypothesis, or the Chamberlain Model in 1904. It was proposed by an American geologist and educator named Thomas Crowder Chamberlain and an American astronomer named Forrest Ray Moulton. It was proposed as a replacement for the Laplacian version of the nebular hypothesis that had prevailed since the 19th century. A star passed close enough to the Sun early in its life to cause tidal bulge to form on its surface that caused material to be ejected repeatedly from the Sun. Because of the gravitational effects of the passing star, two spiral arms would have extended from the Sun. The other material would fall back while other will remain in the orbit to cool and condense to form planets. the filaments cooled into numerous, tiny, solid fragments, planetesimals, and a few larger protoplanets.
Next one is the interstellar cloud theory, or the Sun-interstellar cloud encounter. It was proposed by Otto Yulievich Schmidt, a Soviet scientist, mathematician, astronomer, and geophysicist during 1943. According to him, the Sun in its present form passed through a dense interstellar cloud, emerging enveloped in a cloud of dust and gas, from which the planets eventually formed. Solved the angular momentum problem by assuming that the Sun's slow rotation was peculiar to it, and that the planets did not form at the same time as the Sun.
The next one is the cap year theory, which was proposed by Michael Mark Wilson, a British physicist and a planetary scientist during the 1964. According to this theory, solar system formed from tidal interactions between the Sun and a low-density protostar. The Sun's gravity would have drawn material from the diffuse atmosphere of the protostar, which would have then have collapsed to form the planets.
Last one is the Protoplanet Hypothesis. This is the current working model for the formation of the solar system. It incorporates many of the components of the Nebular Hypothesis, but adds some new aspects of modern knowledge of fluids and states of matter. It was proposed by William Hunter McRae, an English astronomer and mathematician. For about 4.6 billion years ago, in the Orion arm of Milky Way galaxy, a slow-rotating gas of dust and cloud, dominated by hydrogen and helium, starts to contract due to gravity. As most of the mass move to the center to eventually form a proto-sun, the remaining materials form a disk that will eventually become the planets, and the momentum is transferred outwards. High-speed collisions with large objects destroy much of the mantle of Mercury and puts Venus in retrograde rotation. Collision of Earth with large objects produces the Moon. This is supported by the composition of the moons, very similar to the Earth's mantle.
And that's the rival theories that explain how our solar system formed.
Again, I'm Nicole.
I am John David.
And I am Clifford. Hope you enjoy watching.
Thank you and goodbye!